Hi, everyone. It's come to my attention that some of the homework problems are a bit difficult, particularly, okay, so this is on homework 1. Problems 1 and 4 are a bit tricky. Problem 4 is supposed to be a bit tricky because it's a bonus problem. But problem 1 specifically states that you are not supposed to use truth tables. Which is really the only way you guys have seen things done so far. So I wanted to make this video and show you an alternative way to do it, which the professor refers to as formal manipulation rules. And hopefully I won't have to make too many of these videos in the future because we're rearranging, or Dr. Avatisian is releasing the lectures earlier, so we should be able to cover this sort of stuff in section rather than as extra material. Okay, so I'm not going to do any of the problems on the homework, but I'm going to do something similar. So consider this propositional form. Which reads x implies z, or I'll say x implies y, and y implies z implies x implies z. Okay, the first thing I want to note is this probably just looks like a mess of symbols, but you should get in the habit of trying to translate this into English. It's not going to be essential for like solving the homework problems. You can just manipulate the symbols and get away with it and find a solution, but it's helpful if you actually think about these in terms of English, because then it'll stick with you. What this is saying is, okay, if x then y, that's what that first statement in parentheses says. The second one says if y then z, z. And this third one says if x then z. And as the homework is asking, I would like to know, is this a tautology? Meaning, is it always true, regardless of what values I choose for x, y, and z? The answer is yes. This is actually what's called the transitive law. That says, okay, if this holds and this holds, right? So x implies y and y implies z, then indeed x implies z. And it's I could rephrase it, using like algebra. I could have said like if x equals y and y equals z, then well, you better get that x equals z. That better be a true statement, right? So it is tautological to write that mess of symbols down. Okay, so I'm going to erase this so I have more room. By now, hopefully you're used to seeing how to prove this stuff with truth tables, where at the end, the final column would just be like all t's. Again, we can't do that. So what we can do is utilize a couple theorems from the book. Those are going to be theorem 1.1.1, which goes over stuff like the associative, commutative, distributive rules, as well as Demorgan's law. And then theorem, it's 1.2.2, let me check. Yeah, 1.2.2, which goes over other important things. In particular, it includes the fact that the statement P implies Q is the same exact thing as writing not P or Q, which maybe takes a bit of convincing, but I'll let you guys worry about that. These, in fact, have the same truth tables, this statement and this statement. So the theorem includes a bunch of other important stuff as well. not going to write them all down, but please reference your textbook to see what I'm talking about. Okay, so how would I tackle something like this? Well, the reason I wrote this fact down, that these two ways of writing a propositional form are equivalent, is so I can use that here. So let's focus on each chunk individually, each of the chunks in parentheses. So x implies y, according to what I put in this red box over here, I can write that as not x or y. That's equivalent. Okay, so that's me using a formal manipulation rule. It's basically anything from those two theorems. Similarly, let's translate this parenthetical. That would be not y or z. Okay, I'm not going to mess with this implies yet, so I'll just leave that as is, and then I'll focus on the last set of parentheses that'll transform into not x or z. Okay. Erase these underlines. So those two things are equivalent. I could write that as, put like a double equal sign or a double implication between this sentence and that sentence. Sometimes I'll just write equals because I'm thinking about it in terms of algebra, but it's probably more correct to write it that way. Anyway, I'm gonna leave that off just so nobody gets confused. We'll just assume anytime I write one line and then another, all I've done is formally manipulated things, but the truth values remain the same, just like you do with equations. Okay. Next up, what do I want to do here? Well, one thing I could notice is I've started to get rid of all of these implication signs, except for this one. That one's outstanding. So how about I try to get rid of that? Right, it'll be nice if I just have the sort of simpler operations of negation, conjunction, and disjunction. So let's look at this. Order of operations tells us and is the highest priority after parentheses. So really this whole expression here on the left-hand side, I could wrap in parentheses. And maybe you could think about that as, just give it a shorthand and say that's W. Then this implication says W implies blah. And then going back over here, I can translate that into not W or blah. Okay, so not W or blah, which is this. Okay. Now it's probably a good idea to plug back in for W. I just wanted to make that substitution to make that logical leap seem a bit easier. So really this will be not all that stuff in parentheses. So let me just write it all down. Not this whole thing in brackets, I guess I could say. Okay, so we arrive at this statement, which is logically equivalent to this original statement. Why is that nice? Well, there are no more implication signs. I've gotten rid of all of them. And now, hopefully, I should be able to do stuff with Demorgan's laws. Okay, Demorgan's laws were something in theorem 1.1.1 that I'll write down now. So theorem 1.1.1 contains a ton of things, but two of the things it includes are, or sorry, I said Demorgan, I meant to say distributive laws. So the distributive laws look like this. P, if I ever have an expression like this, P and Q or R, that's logically equivalent. So I'm going to use that double implication sign to P and Q or P and R. Okay, it's sort of, well, yeah, it's sort of similar to like if and was multiplication and or was a plus, right? Then I would have PQ plus PR, which is, PQ plus PR. That's how I think of it. Of course, the next distributive law kind of defies that intuition, because here, if I swap those ands and ors around, this would be like P plus QR, which you can't simplify or rewrite, but with logical propositions, you can rewrite this, and this looks like P or Q and P or R. So it's a little different than addition and multiplication, but there you go. All right, so we have those two facts. I could use that down here. So let's give that a shot. Maybe I'll skip to another page. So let's add a page, and I think I can go back, can't I? Yeah. Cool. Yeah, so I can switch between these. That's helpful. Let me just write this down. So what we had before was, and it's going to take me a second, not X or Y. And something else, what went in there? Not Y or Z. Okay, and then that was ORed with not X or Z. So it's quite a big mess. And yeah, let's start working with this. So that's going to be equivalent to, here's another rule that I should have written down. When you have something that looks like this, okay, so this is Demorgan's, not P and Q is the same as not P or not Q. So you kind of distribute the not sign and then swap the and to an or. So I could do that here, distribute the not. So it would be not this and, or well, the and will become or, not this. Okay, so that will look like not X or Y. Swap the and to an or, not Y or Z. Okay, maybe I guess I don't need parentheses anymore. Then I'll just copy down this last bit here. Okay, and then again, I have a not in front of a logical expression and another not in front of a logical expression. So I could sort of distribute that in, this time using another variant of Demorgan's laws. The negation of a disjunction is the conjunction of the negations. I basically put the not on all the terms and then swap the or to an and. So it's just kind of the opposite of what we did last time. So not X is going to give me X. Swapping the or to an and then not Y. Maybe I'll keep this in parentheses, but I don't have to. So just for clarity, I'll do that. Then we get not Y, which is Y. Swap the or to an and we get not Z. Okay, and then I'll just copy this last one down. Cool. All right, so hopefully things are looking a bit nicer, but I have a feeling they're about to get worse. So what we could do now is mess around with the distributive law again. Of course, this is going to be more complicated because it's sort of going to be like foiling, which is going to make things expand quite a bit. Let me make sure I want to do this some other way. I think that'll be easiest. I think that's really the only approach, honestly. Okay, so let's focus on just two of these terms. Let's kind of foil these together, okay? And the formal way to do it is going to go like step by step, but I'm just going to skip around and say we can actually foil, and maybe you'll trust me on that. So foiling would be like, okay, I get X, I'll look at my first terms, X and Y, right? And what I need to do is use this operation between them. Okay, so x or y. And then I'll combine that with the outer terms and the inner terms and the last terms. So if I do that, that's x or y. Maybe I'll keep that in parentheses. And I'm just going to get 4 terms here anded together. So let me just do that. And then write this final term on the end. Okay, just so we have some template and we have an idea of what's going on. All right, where was I? So that's x or y. And then I want to do, let's get rid of this, x or not z. And on your homework, you might want to go through and like verify why we can do this foiling operation. The next terms will be the y terms. So well, the not y terms. So not y or y. And then not y or not z. So it's super similar to like algebra with your standard variables. It's just you're using different operations. There's slightly different distributive rules. There's this thing called Demorgan's laws. Okay. So we have this. What I want to notice is this is a bunch of ands, and then it's ORed with some other propositional form. Okay. Another thing to notice is one of these pieces is pretty interesting. This not y or y is actually a tautology in its own right. Not y or y is a tautology because it's always true, regardless of what value you assign y. Right? If y is assigned true, then that statement looks like not true or true. If y is assigned false, that statement looks like not false or false. Okay, this is the same as, well, not true is false. So this is false or true. Whereas this one, not false, would be true. And in either case, I have a true. Right? And true ORed with anything is true. So regardless of what value I assign at the beginning, I get true at the end, meaning it's a tautology. Okay. And some other stuff we know about tautologies is that, well, let me phrase it a little differently. If this piece of the propositional form is a tautology, spelled that wrong, well, it means it's always true. I could sort of just replace it with a T, but that's actually equivalent to just leaving it out. And again, you might think about why that's the case. Maybe I'll spoil it for you here. This whole thing, those first 4 terms that are anded together, are going to be true or false regardless of this. Right? If we know this is true, it doesn't have any effect on the truth of the rest of the statement. Right? For this statement to be true, all of them have to be true. So we can kind of leave that out. Let me erase some of this. Actually, let me kill this. Okay. All right, and let's see, what's the easiest way to approach this now? You know what? Maybe I'll leave this in. So we can leave it in. It won't hurt anything. But whenever you see a tautology, consider whether or not you can remove it or whether it has some other effect on the statement. I'll leave it in for now. And what we're going to focus on is I have this ORed with this. And I want to, again, make a little substitution. And maybe I'll call this P. And so I'm really looking at P ORed with not X or Z, okay, which is equivalent to P or not X Oops, sorry, I'm making a mistake here. I'm applying the distributive rule when I shouldn't be. These are both ors. So when they're both ors, you can actually just kind of get rid of the parentheses. Let me think about this then. I probably want to mess around. As you can see, this requires a bit of thought. I'm going to mess around with just this term then. And I'm going to start combining some of the ands here. Because it's much nicer if you can just get, if you can get to a simpler place. So what I could look at, for example, are, let's see. Oh, yeah, no. I was doing it correctly. Right, so focusing on these two separately, I just want to give slightly different names to these things. So I'm going to say this is, what name should I give them? I'm thinking if I want to just kill this guy off after all. Yeah, let's kill that guy off. And then let's name these P and Q and R. Okay, and then that's ORed with that expression. Okay, so the reason I'm going to do that, P and Q and R. I'm using a shorthand and assigning new variables just because I want to make my life easier. Because what I'm about to do is I'm about to like foil all this mess together, and it's going to get pretty ugly. So stick with me. Let's see, do that. Yeah, so that should be, yeah, I'm not going to exactly foil. Let's make our lives easier. So I'm going to do P ORed with everything on the right side. Okay, so that's my first term done. Then I'm going to do Q ORed with everything on the right-hand side. So, and Q or not X or Z. Okay. So that's Q done. And then R, and R ORed with everything on the right-hand side. So that's R done. Okay. And now I could kind of distribute in each of those if I wanted to. But I don't think I'll have to, because let's go ahead and replace P, Q, and R with their assignments up here. So this will look like, okay, P was X or Y. Okay, then for this second bracketed term, Q is X or not Z. And then I'll write down the rest of it. This final term, R was that piece, not Y or not Z. ORed with not X. Okay. And it looks like I've just made it more complicated, right? But the nice thing here is all of these are ORs, right? Within any of the pairs of brackets, I just have ORs. And everything here is associative by one of those theorems. I forget which one. So I really don't need the parentheses. I could just, oops, kill all of these. Okay, so I'm looking at something like that. Maybe that's a little bit nicer. And then what I want to focus on is something very nice. The very nice thing is I have X or not X. Okay, again, since they're all ORs, the OR operation is commutative. So I could rearrange these within the brackets if I wanted to. So I'm just looking at those terms because I could rearrange them to be right next to each other, X or not X. What else do I have? I have the same thing here, X or not X. And then over in the final pair of brackets, I have not Z or Z. Okay, why am I highlighting those? Those are tautologies. Okay. X or not X, I think we just saw this, is a tautology. Because if X is true, we're done. If X is false, not X is true. So at least one of them is always true. Okay. And tautologies, when they're mixed up with a bunch of or statements, well, an or statement is true if one of the pieces is true. So this piece is true. These, when I combine them, that's true. These, when I combine them, that's true. And so it literally does not matter what Y and Z are here, or what not Z and Z are here, or not Y and not X. It doesn't matter because I'm ORing it. And ORing with true always gives true, regardless of whether the other terms are false. Okay, and then I have true and true and true tautology. Okay, so that's kind of a lot of work. But that's what you're hunting for. You're trying to simplify these things using Demorgan's laws and the distributive laws and a couple other things that come up here and there. So eventually you can find mini tautologies, like the things I circled in red, and then hopefully combine them into one big tautology. And I think the problems on the homework are easier than this one. This was just the only one I could come up with that wasn't a homework problem. So, except for maybe the bonus problem. I haven't tried that one myself, so maybe that's harder. Who knows? But yeah, I hope this helps. And yeah, good luck and have a good weekend. I will see you guys next week.